What if everything you were taught about the history of science was a carefully constructed lie? What if the period we call the Dark Ages wasn't dark at all, and someone, deliberately, made sure you'd never find out?
The year is 500 AD. Rome has fallen, Europe is in chaos, churches replace libraries, scholars are executed, and for the next 1,000 years you've been told, nothing happened. The lights went out. Progress stopped. Humanity waited in darkness for the Renaissance to rescue it. That's the story they taught you in school. And it is spectacularly wrong. Because while Europe slept, something extraordinary was happening just a few hundred miles to the east. In Baghdad, in Toledo, in Cordoba, in cities so advanced, so scientifically alive. Today, we're going to unbury what was lost. We're going to name the names they erased. Modern historians have spent decades trying to understand how we managed to forget them. Describe the machines they destroyed, and ask the question no textbook has the courage to answer. Why were these innovations buried? And who benefited from hiding them? The Dark Ages lie, what historians got wrong. The term Dark Ages was invented in the 14th century by an Italian poet who'd never even visited the places he was describing. It's one of the most successful propaganda campaigns in the history of human knowledge. Let's start by dismantling the lie at the very foundation. The phrase Dark Ages was coined by Francesco Petrarch, an Italian poet writing in the 1330s. He wasn't a historian, he wasn't a scientist. He was a man with a political agenda.
To make the ancient Roman era look glorious by comparison, and his own Italian Renaissance look like a heroic recovery. The darkness he described was largely fictional, and scholars have been correcting this mistake for decades.
The early Middle Ages, rough 500 to 1000 AD, they were differently lit. The question is, whose torch do you choose to follow? Because when you look at Europe through a Eurocentric lens, yes, it's a period of fragmentation, plague, and the collapse of Roman infrastructure. Look at the whole world, and suddenly you see a civilization in the Islamic world advancing at a rate that should make every modern scientist blush with envy. Universities, observatories, hospitals with specialist physicians, public libraries with 500,000 books, decimal mathematics, navigation tools accurate to within a fraction of a degree. All of this between 700 and 1200 AD. All of this largely forgotten in the Western curriculum. The University of Bologna, often cited as Europe's first university, was founded in 1088. But Al-Qarawiyyin in Fez, Morocco, still operating today, was founded in 859 AD by a woman named Fatima al-Fihri. It predates Bologna by over 200 years. Chapter 3, the Baghdad House of Wisdom. At its peak, the House of Wisdom held more books than all of Europe combined. It employed hundreds of scholars, paid them government salaries, and translated every piece of Greek, Persian, Indian, and Chinese knowledge it could find. Then, in 1258, the Mongols arrived and burned every single page. In the year 830 AD, the Caliph Al-Ma'mun built something that the world had never seen before, and some historians argue he called it Beit al-Hikmah, the House of Wisdom. And it was exactly what it sounds like, a palace dedicated entirely to the pursuit of knowledge. Scholars from every religion, every ethnic background, every corner of the known world were invited and paid handsomely to come to Baghdad Annotated, improved, and expanded. Euclid's geometry, Galen's medicine, Aristotle's philosophy. All of it saved and then surpassed. And translate, debate, discover. Greek texts that had been moldering in Byzantine monasteries for centuries were brought here, translated into Arabic. The mathematician Al-Khwarizmi worked here. His name is where we get the word algorithm. His book, Al-Kitab al-Mukhtasar fi Hisab al-Jabr wal-Muqabala, the compendious book on calculation by completion and balancing, is where we get the word algebra. This man, working in the 9th century, laid the mathematical foundation for every computer ever built.
And then, in February 1258, came the Mongol army of Hulagu Khan. Within 2 weeks, 400 years of accumulated human knowledge was thrown into the Tigris River. Witnesses wrote that the river ran black with ink. The scholars were executed. The House of Wisdom was gone.
What was lost that day, we will never fully know. But what survived, what had already spread to Spain, to Sicily, to the edges of Europe, that's what eventually ignited the Renaissance. Real example, Al-Khwarizmi's algebra text, written around 820 AD, was so comprehensive that Latin translations of it were used as university textbooks in Europe until the 16th century, 700 years after it was written. Chapter 4. Al-Jazari's Mechanical Marvels, Robots Before the Renaissance. In 1206 AD, an engineer built a programmable musical robot band that could play different songs. He built an automatic hand-washing machine with a feedback mechanism. He built a water clock that displayed the time using mechanical figurines. His name is almost entirely unknown in the West. And then, that is not an accident. His full name was Badi az-Zaman Abul Izz ibn Ismail ibn al-Razaz al-Jazari. We'll call him Al-Jazari. He was a mechanical engineer, working in southeastern Turkey in the late 12th and early 13th centuries. And the book he left behind, the Book of Knowledge of Ingenious Mechanical Devices, with Inventions, describes 100 mechanical inventions so sophisticated that engineers are still studying them today. Let's talk about his elephant clock, a towering automaton several meters tall, powered entirely by water. Every 30 minutes, a mechanical bird chirped, a dragon tipped, and figurines moved in a precisely choreographed sequence. It used a float and siphon mechanism, the same principle used in modern flush toilets. Built in 1206 AD. Then there's his programmable robot band, 4 mechanical musicians mounted on a boat, driven by a rotating pegged cylinder, the exact same principle as a music box. By adjusting the pegs, the machine could play different songs. This is, by any serious definition, a programmable device. Built 600 years before the Industrial Revolution. His hand-washing automaton is perhaps the most remarkable. A mechanical servant would pour water over the user's hands, offer soap, then offer a towel. All automatically, triggered by a chain pull mechanism with a feedback loop. He described it as a device that preserved the master's dignity. It was, functionally, the world's first automated domestic robot. How did Europe respond to this knowledge? For centuries, it largely didn't. Al-Jazari's manuscript was copied and preserved in Ottoman libraries. A few translations circulated. But his name never entered the Western canon of science heroes. The list that includes Leonardo, Galileo, Newton. Ask yourself, why? Real example, Al-Jazari's crankshaft design, converting rotational motion to linear motion, is a fundamental mechanism in every combustion engine ever built. He described it in detail in 1206 AD. The first similar European description appears 250 years later. We haven't even gotten to the man who invented the scientific method 700 years before Descartes. Or the woman who ran a medical school in 10th century Salerno. Stay with me. This gets stranger. Chapter 4, The Lost Medicine, Surgeons and Pharmacists of 900 AD. In 10th century Cordoba, there was a surgeon performing operations with instruments he designed himself. Instruments so well engineered that versions of them are still used in operating rooms today. His textbook on surgery was used in European medical schools for 500 years. His name? Almost no one in the West knows it. Abu al-Qasim al-Zahrawi was born around 936 AD in a small town outside Córdoba, in what is now Spain. He spent his career as a court physician and surgeon to the Caliph, and over the course of his lifetime produced a 30-volume medical encyclopedia called Al-Tusri, The Method of Medicine. The final volume, dedicated entirely to surgery, was unlike anything the world had produced before. He described over 200 surgical instruments, illustrated them in meticulous detail: scalpels, forceps, retractors, bone saws, catheters, surgical needles. He invented the catgut suture because he observed that unlike other intestine to stitch wounds, it dissolved naturally in the body without needing removal, using animal intestine to stitch wounds. We still use a version of this today. He described the use of plaster of Paris in casting broken bone. He performed C-sections. He operated on the skull. And he did all of this with a sophistication that European medicine would not match for 500 years. And then there is Ibn Sina, written around 1025 AD, systematized everything known about medicine, pharmacy, and anatomy into a single coherent system. It was translated into Latin in the 12th century and used as the standard medical textbook at Oxford, Paris, and Louvain until at least the 17th century. For 600 years, medical students across Europe were learning medicine from an 11th century Persian Muslim scholar. But here's what's almost never mentioned. Ibn Sina's canon described quarantine as a method of disease control in 1025 AD. The concept of contagion, that disease passes between people through invisible agents, was documented by Islamic physicians centuries before the germ theory of disease was officially developed by Pasteur and Koch in the 1800s. Real example, Al-Zahrawi's surgical instruments, illustrated in Al-Tusri circa 1000 AD, include a form of the obstetric forceps. The device was supposedly invented in 17th century Europe. The Arabic predecessor predates the claimed European invention by 600 years. Every scientist in every field, in every country, right now, is using a method of inquiry developed by a man born in 965 AD in what is now Iraq. His name is Ibn al-Haytham. And the textbook history of science has, until very recently, essentially pretended he didn't exist. The scientific method, the practice of forming a hypothesis, designing a controlled experiment, observing the results, and revising your theory accordingly, is the most powerful intellectual tool humanity has ever developed. We attribute it, in Western history, to Francis Bacon in the 17th century, or to René Descartes, or to Galileo. The real story is different. Ibn al-Haytham, born in Basra in 965 AD, wrote a book called Kitab al-Manazir, Book of Optics, completed around 1027 AD. In it, he systematically demolished a 1,000-year-old theory that had gone unquestioned since ancient Greece. The idea that the eye emits rays of light to see objects. He called this ridiculous. And then, crucially, he didn't just argue against it philosophically. He designed experiments to prove it was wrong. He built the first described camera obscura, a darkened room with a small hole that projects an inverted image of the outside world, and used it to study the properties of light. He discovered that light travels in straight lines. He studied refraction, reflection, and the anatomy of the eye. His explanations of how we perceive depth and distance were not significantly improved upon for 6 centuries. But the most remarkable thing is his methodology. In passage after passage of the Book of Optics, he explicitly describes what we now call the scientific method: propose, experiment, observe, revise. He applied it systematically across 7 volumes to the study of light. And when his Latin translation, De Aspectibus, reached Europe in the 12th century, It didn't just teach European scholars about optics, it taught them how to do science. Roger Bacon, writing in the 13th century, directly cited Al-Haytham. Kepler, in the 17th century, built his theory of the eye directly on Al-Haytham's work. Leonardo da Vinci's notebooks on optics are essentially a conversation with a man who died 500 years before him. The UN declared 2015 the International Year of Light, partially in commemoration of the 1000th anniversary of Ibn al-Haytham's Book of Optics. NASA named a crater on the moon after him. He still doesn't appear in most high school science curricula. Every time you use the word experiment, you're using a concept that Al-Haytham formalized in 1027 AD. Chapter 6, Agricultural Revolution, Forgotten Farms that Fed Empires. Between 700 and 1100 AD, Islamic agricultural engineers quietly transformed its supply of 3 continents, introducing crops that today feed billions of people. Cotton, hard wheat, sugarcane, citrus fruits, rice, spinach, artichokes, all introduced to Europe and Africa through a deliberate, systematic agricultural revolution that is almost never taught. Food is civilization. If you can't feed your people reliably, nothing else matters. No art, no science, no philosophy. And one of the greatest technological achievements of the early Middle Ages was an agricultural revolution so sweeping, so consequential, that historians have given it a name: Islamic Green Revolution. Between approximately 700 and 1100 AD, Muslim traders, scholars, and farmers facilitated the transfer of dozens of crops from their native regions across the Islamic world and into Europe. Hard wheat from Persia, the basis of pasta and bread, spread westward. Cotton from India reached Spain and North Africa. Sugarcane spread from Southeast Asia across the Middle East into the Mediterranean. It was in the water. Islamic hydraulic engineers developed and systematized irrigation techniques, the Qanat underground canal system, Nouria's water wheels, and sophisticated reservoir management that transformed arid land into farmland. The agriculture of medieval Cordoba was so productive that the region supported a population density that southern Spain wouldn't reach again for 800 years. Islamic agronomists also developed the first agricultural science. Ibn al-Awam's 12th century Book of Agriculture describes over 580 plants, discusses crop rotation, fertilizers, and grafting techniques, and remains one of the most comprehensive agricultural texts ever written. It was translated into Spanish in the 1800s, and the word all traveled together along Islamic trade routes before reaching European tongues and tables. Chapter 7, Early Chemistry. Al-Kindi's Secrets of Distillation. The perfume industry, the pharmaceutical industry, the alcohol industry, the petroleum industry. All of them trace their core processes back to distillation techniques described in Arabic texts from the 8th and 9th centuries. The man who systematized it all is called the father of chemistry. His name is Jabir ibn Hayyan. You almost certainly don't know him. Jabir ibn Hayyan, known in medieval Europe as Geber, was a polymath born around 721 AD. He is credited with the development or early description of over 20 fundamental chemical processes, including distillation, crystallization, calcination, sublimation, and the preparation of acids. His laboratory notebooks describe experiments with a rigor that anticipates modern chemistry by nearly 1,000 years. He described how to produce sulfuric acid by distilling iron sulfate and nitric acid and aqua regia, the mixture strong enough to dissolve gold. Distillation techniques of extraordinary sophistication. This 9th century text is, in effect, the world's first industrial chemistry manual. The word alcohol is Arabic. Alkali is Arabic. Alembic, the distillation flask, is Arabic. Elixir is Arabic. When European alchemists began serious work in the 12th and 13th centuries, they were working almost entirely from Arabic Latin translations of texts that Jabir and Al-Kindi had written 400 years earlier. Robert Boyle, Newton's contemporary and one of the founders of modern chemistry, had Jabir's Latin translations on his bookshelf. The chain of knowledge is direct, unbroken, and studiously under-acknowledged in the history books. He developed techniques for purifying metals. He studied the properties of salts. And he did all of this not through mystical alchemy, but through systematic experimentation and careful documentation. His contemporary, Al-Kindi, took these chemical techniques and applied them to something unexpected, the perfume industry. Al-Kindi's book of the chemistry of perfume describes over 100 recipes for perfumes and aromatic waters. If you're still here, that means you are the kind of person who actually wants to understand the world. Chapter 8: Astronomy's Hidden Giants, Maps that Guided Columbus. When Columbus set sail in 1492, the navigational instruments he used and the star charts he consulted and the mathematical techniques his navigators employed were all, directly or indirectly, derived from Islamic astronomers who had mapped the heavens 500 years earlier. Columbus found America using tools he didn't invent. By the 9th century, Islamic astronomers had already corrected significant errors in Ptolemy's model of the solar system. Al-Battani, born around 858 AD, calculated the length of the solar year to within 2 minutes of its modern known value. He determined the obliquity of the ecliptic, the tilt of the Earth's axis, with extraordinary accuracy. His calculations of the precession of the equinoxes were more precise than anything Ptolemy had produced. Al-Biruni, writing in the early 11th century, proposed, with mathematical arguments, that the Earth rotates on its axis. He also provided a remarkably accurate estimate of the Earth's circumference, and suggested that a continent might exist between Europe and Asia on the other side of the globe. This was in 1025 AD. Columbus sailed in 1492. Then there is Muhammad al-Idrisi. Working in 12th century Sicily for a Norman king, he produced a world map, the Tabula Rogeriana, that was the accurate map of the world produced until the 16th century. It showed the known world in unprecedented detail: coastlines, rivers, mountains, trade routes. Al-Idrisi drew it upside down by our modern conventions, with south at the top, following Islamic cartographic tradition. The astrolabe, the device Columbus navigators used to determine latitude by measuring the angle of stars, was refined to extraordinary precision by Islamic craftsmen. Over 1,000 medieval Islamic astrolabes survive in museum collections today. Each one is a precision instrument of breathtaking beauty, handcrafted, individually calibrated. European navigators used versions of this Islamic technology to reach every continent on Earth. Real example, Al-Idrisi's 12th century world map remained in use by European explorers for 300 years. A large silver version was commissioned by Roger II, Sicily, a Norman Christian king who hired a Muslim scholar to map the world, because no European of the time could do it better.
Chapter 9: The Women of Medieval Science, Erased from History. The history of medieval science already suffers from a cover-up. But within that cover-up, there is a second, deeper erasure: the systematic removal of women from the record. The women who ran hospitals, founded universities, wrote medical texts, and cataloged plants are doubly invisible. Today we name some of them back. We've already mentioned Fatima al-Fihri, the woman who founded the University of Al-Qarawiyyin in 859 AD. In 11th century Salerno, Italy, there existed a group of female physicians known as the Ladies of Salerno, or Muliere Salernitane,
Observe the humerus balance. This guides our healing.
who practiced and taught medicine at the Scuola Medica Salernitana, Europe's first medical school.
The balance of the humors is essential for health. We must observe each patient carefully. Most famous was Trotula of Salerno, whose 3 medical texts on gynecology, cosmetics, and women. These texts guide our understanding of women's health and healing.
These medicine were copied across Europe for centuries.
Whether Trotula was one person or a composite figure is still debated. But the texts existed, were used, and were eventually attributed to male authors in later copies. Then there is Hildegard von Bingen, the 12th century German abbess who wrote Physica and Causa et Curae, comprehensive texts on the
medicinal properties of plants, animals, and minerals. She described 230 plants and their medical uses. She wrote about the circulation of blood in ways that predated Harvey's celebrated work by 450 years. And because she was a mystic as well as a scientist, her scientific work has been dismissed, ignored, or treated as folk medicine for generations.
The pattern is consistent. Women's scientific contributions in the medieval period were copied, used, and then attributed to men, forgotten, or dismissed as unscientific. The erasure was not accidental. It was institutional.
Finally, the question that remains: closing and call to action.
We began this video with a question: what if the history of science you were taught was incomplete? I hope after this video you agree that incomplete, intent, is a generous word for it.
Al-Khwarizmi gave us algebra. Al-Haytham gave us the scientific method. Al-Zahrawi gave us modern surgery. Al-Jazari gave us programmable machines. Ibn Sina gave us systematic medicine. Al-Idrisi gave us the world map. Fatima al-Fihri gave us the university. And dozens more, men and women, Muslim, Jewish, Christian, Zoroastrian, working side by side in the greatest intellectual collaboration in pre-modern history,
Gave us the foundation on which all modern science rests. Their names were not erased by accident. They were buried in a historical narrative that served a particular power structure in a particular era for particular reasons. That era is over.
the work of recovery is underway. And every time someone watches a video like this one, every time a name is spoken that was meant to stay silent, a small piece of that burial is undone. The next time you solve an algebra problem, remember Al-Khwarizmi. The next time you go to a hospital, remember Al-Zahrawi and Ibn Sina. The next time you look up at the stars, remember Al-Battani and Al-Biruni. The next time someone tells you the Middle Ages were dark, tell them the truth. The lights were on. You just weren't looking in the right direction. If this video changed the way you see the history of science, share it. Not for this channel, for the names that deserve to be known. Subscribe. The next video goes even deeper.